Olli Seppänen, and Emil Zankul. And you are?
Malik Khan.
Thank you.
Okay, thank you. So good morning, everybody. I am Malik Ghanem. I am a master's student at the American University of Beirut, Lebanon. And I will be sharing with you a paper done as a new perspective of construction logistics and production planning. This is part of my thesis that I am working on with Dr. Farouk Hamzi and Dr. Olli Seppänen. Through this presentation, we will start with an introduction, then a brief literature review, then shed light on the research gap concerning construction logistics and production planning at the level of locations within a construction project, then explain and demonstrate how push and pull techniques could be applied in material replenishment approaches and production control. Then explain how this research gap could be addressed in future research, and finally conclude. So this is the title of the paper, A New Perspective of Construction Logistics and Production Control. So the main two constituents of this title is construction logistics, which could be divided into supply chain management and site material management. So to start with supply chain management, it could be defined as a set of approaches used to utilize efficiently suppliers, manufacturers, and warehouses to deliver, in our case, information, material, funds, and services into construction site, keeping an eye on the consumer's value, customer's value, such as safety, quality, cost, and time reduction. Then site material management may be defined as allocating spaces for resource delivery, storage, and handling in order to reduce site congestion, excess material movement, and other inefficiencies. Moving to production planning and control, planning may be defined as identifying activities, then selecting and ordering them in order to be executed in an efficient way. So production planning and control is mainly planning, designing, making, and then controlling. There are different ways of regulating workflow in production planning and control. So theorists define mainly two behaviors. Push, which is mainly applied in CPM on critical path method. It is mainly releasing material based on preset schedule and preset dates. Whereas the pull technique, which is mainly applied in last planner system and location-based management system, it pulls the tasks from milestones and schedules, and as well as from their need downstream. So after doing a thorough literature review on production planning and control, it was noticed that push and pull techniques were studied and applied and compared with each other from a scheduling and control perspective. However, far less attention has been put into the effect of push and pull techniques on crew productivity, crew allocation to areas, and crew interactions at the level of locations within a construction site. So we're going to explain this in the coming slides as well. And if we move to material tracking and process optimization as part of the construction logistics, it was noticed that the material and tracking and optimization happen through different stages of the supply chain management, starting from production into warehousing, then to delivery until reaching the construction site, where the material is considered that it reaches the final destination. However, this material still needs to be hauled to the workplaces where it should be installed. So if we zoom into this construction site, it could be noticed that it is still like a black box. Some researchers address this black box through different approaches. Some studied the effective site layout. So the main aim was to reduce transportation costs and hauling distances. Other studies addressed labor productivity, however, from material storage techniques. So they suggested that improper material sorting, material shortage, and other factors could affect labor productivity. However, labor productivity is still affected by other factors, such as on-site material logistics, which gained far less attention in the literature. So be it push or just-in-time techniques applied at the level of location have different effects on labor productivity, and this paper targets these techniques. So we are not studying workplaces as one item. It is now broken into different items, and the material, how the material is being held between these workplaces, between the storage location, is to be studied in this paper. So to make things more clear, let's consider an example of a construction site. We are going to show how push technique is applied at the construction site. So if an activity is, has finished there in this location, and the crews are going to move to perform the same activity at a different location. So they may have three alternatives, 1, 2, and 3. The material used for these activities are indicated by this green symbol. So here the material, as we can see, it is very close to where it should be installed, whereas here it's farther, and here it's even farther and farther. Considering the crews, other crews working in the same location, which may cause congestion, in this example here we have one crew working in the same location. Here we have more crews, and here even more and more crews. So this place is considered to be congested. If we are following a push technique, and it happened that this activity is on the schedule that should be, and it should be executed right now, the crews have to move into this activity, into this location, without considering the other two alternatives, which might help them work more productively, as we can see. So if we were following a pull technique on production on the construction site, all of these alternatives, if we continue, we have the material distribution on the areas and the congestion. All of these alternatives are considered, and the place that the crews are going to move to is you know, their decision is based on the congestion and on the schedule and the material availability as well. Moving into into the material replenishment technique, if we consider the push technique, where the materials are being replenished based on a preset schedule, we could notice that the material may be sent to a location based on this schedule, and this material, which is for activity B, may not be used straight away, and the materials and the crews for activity A, which have to perform this activity here, may reach this location and find that materials for other activities are causing obstruction. So they have different alternatives that they can work on. So they could work with or without decreased productivity, depending on the level of congestion, on the level of obstruction these materials can cause. They could move the material or call the other crews to move them, or they could change their location if this material is causes complete obstruction and they cannot handle them, or they could wait until things are being resolved. So as we can see, a push technique shows how it could affect productivity of workers on a construction site. Whereas if we follow just-in-time on-site material replenishment technique, the crews that are going to move into this location can send an order to the storage location, and the material is being replenished based on the order, the actual order. So with the right amount and at the right time and to the right location. Then the material the crews can move into the location and work productively. Okay, so with this, after shedding light on this problem and this gap, which is the effect of different techniques, push and pull, at the level of locations, we can suggest how future research can address this gap. So we can test and compare the effects of push and pull on production control and construction logistics at the level of locations again, and test the following propositions. So overmanning, which is usually used in push techniques, could be counterproductive if adapted to finish a project that is not on time. Pull can increase productivity and production rate. However, push can only increase production rate. Pull achieves shorter cycle time and decreased cost, and pull in production planning should be accompanied by a pull in production control and not pushing what has been pulled in the production planning. So to conclude, extensive research has been done on construction logistics and production planning at a higher level. However, far less attention has been put into the construction logistics and production planning at the level of locations, as we demonstrated in the previous figures. Applying a push technique for material replenishment to workplaces show negative effects on productivity, and this could be avoided by the using of just-in-time material logistics between locations. Push and pull techniques in production control are compared based on their effect on the general project performance without going deep into the level of their effect on labor productivity. So this paper added this missing layer through showing how a push method reduces crew productivity despite increasing production rate, and hypothesizes new propositions that could be addressed in future research. Thank you. This is all. Questions are left to the end. Thank you.
Very much, Malik. Please stay where you are. Could I ask all the speakers to come out to the front?